Hi, it's Professor Monty. We're looking at rationalizing the denominators when we only have one term. Okay, so a big rule here is a fundamental rule of algebra is no radicals can be in the denominator. Now I say in algebra because when you get to calculus, they let you have radicals in the denominator. They usually don't care. So, but for algebra, no radicals in the denominator. So our goal, we want to get the denominator to be a perfect square or a perfect cube, etc., whatever the radical is, and then we can simplify. All right, let me show you some examples. So I start off, I've got the square root of 3 halves. And remember what this really means, that's the square root of 3 over the square root of 2. Well, I need to get the denominator so it's not a square root. So I need to get the square root of 2 to be the square root of something I know. Well, the easy thing is the square root of 4. So if I multiply this by the square root of 2, well, if I do it to the bottom, I have to do it to the top. Because now I'm multiplying by 1, I'm not changing the value. But when I multiply these across the top, it becomes the square root of 6. But the bottom is the square root of 4, which we know simplifies just to 2. So I get the square root of 6 over 2. It doesn't look necessarily any prettier, any better than what I started with, but there's no radical in the denominator, and that was our goal. So we've rationalized the denominator. The denominator before was the square root of 2, which is irrational. Now it's just 2, which is rational. We've rationalized the denominator. All right, so let's do that the rest of these. Okay, so I look at this one. Again, now it's already broken into 2 fractions, but this 5x can't be down there under the radical. The 3 is already outside of the radical. Don't confuse with this the third root of 5x. That's what the third root would look like. This is just 3 times the square root of 5x. So again, the stuff under the radical I need, so whatever I do to the bottom, I do to the top, multiplies things under the radical together. So what I'm going to get is on top, I'm going to get 4 times the square root of 7 times 5 is 35x. And the bottom, I've got this 3, but inside is 25x squared. Some students will skip that step and just put 5x, and you're welcome to do that. I like to see that it's perfect. So, oh, the square root of 25 is 5, the square root of x squared is x. So I've got 4 times the square root of 35x. And on the bottom, 3 times, well, the square root of 25 is 5, the square root of x is x. And now I just multiply to get my answer. So 4 times the square root of 35x all over 15x. One of the x's is under the square root, the other's not, so I can't reduce. The same with the 35 and the 15, I can't reduce those. If I could reduce the 4 and the 15, I could. But they're what they call relatively prime. Okay. But again, no radical in the denominator. Let's look at another one. This time I have a third root, makes it a little trickier. So I've got the third root of 5 over the third root of 9. And what some students like to do is they like to say, oh, Professor Monty, I know how to do that just like we did up here. I'm going to multiply by the third root of 9. But if I do that, I'm going to get the third root of 81. 81 is not a perfect cube. So I have to be a little bit smarter. So let's erase that. What I like to do is I like to say, oh, you know what? This 9 is really 3 squared. So I really have the third root of 5 over the third root of 3 squared. And since I have a third root, I'm looking for something in the third. Oh, I already have 2 3's. I only need 1 more. So now if I multiply by the third root of 3, top and bottom, on top I multiply, I get the third root of 15. And down here you can look at it one of 2 ways. You can say, oh, that's the third root of 3 cubed. Or if you wanted to, you could call it the third root of 27, and maybe you know the third root of 27 is 3. But here we know the third root and the third power just cancel out. I just get the 3 on the bottom. And the top's the third root of 15. And again, I've rationalized the denominator. All right. One more. This time I have a 20. The 20 is not nice, and I can't even think of a nice cube with 20. So I'm going to go over here. I'm going to see what makes up this 20. Let's see. 2 goes into 20 10 times. 2 goes into 10 5 times. So this is really 6x on the top, but the bottom is really 2 squared times 5. and I've got the square root of that. What I actually wanted the cubed root of that. Let's make it a cubed root, and we'll go from there. Put the cube inside there. So that'll make it more interesting. Let's do a cube root like we did on this one. So now I need 3 of these. So I need 1 more 2, but 2 more 5s. So what I'm going to multiply is the cubed root. I need 1 more 2, but I need 2 more 5s. And I do the same thing on top. And so what I get, notice, on the top I have the 6x. This is the cubed root. Well, it's 2 times 25. And then we'll, 2 times 25. We'll multiply that out in the next step. But on the bottom, I get the cubed root of what? I had 2 squared times 2, that's 2 to the third. And I had 5 times 5 squared, that's 5 to the third. So now I have 6x times the cubed root of 50. And then down here, notice that's an 8 times 125. I don't even care. Because I know the cubed root of 2 cubed is 2, and the cubed root of 5 cubed is 5. So that's just going to be a 10 on the bottom. So I get 6x cubed root of 50 all over 2 times 5 is 10. So a bunch of work there. This is a 2x. So I'm looking, you want to make sure that it looks like the cubed root of 50, not 6x cubed, because it's just 6x times the cubed root. So be careful with your notation. But again, I rationalized. We can actually do one more step here, because since these are both on the outside, 2 goes in there 3 times, 2 goes in there 5 times. And so my answer, I'll just squeeze it in right here, 3x times the cubed root of 50 all over 5. Makes it look a little bit more like a 50. All right, so these take some practice and then you go through, but practice is going to pay off because the more you practice, the quicker you'll do, the more often, obviously, you'll get the right answer. So stick with it and you can do it.